Hi, hello. Today, I wanted to talk more about Suricata, the intrusion detection system with XDP DDoS protection. For example, for SymFlat DDoS protection. I had a previous video talking about this, and this time I'm going to talk about how to run Suricata and XDP SymFlat protection in a Docker container, so it is easier to deploy. So here is Docker Suricata GitHub repo. I forked from Jason from his repo. I make a few changes and which is here under this 6.0, which is for Suricata version 6. So since this is for x86, so we are going to look at this Docker AMD64 file that I made a change. So instead of build the Docker container from the Ollama Linux, I switched to Ubuntu 24.04, which is the very most recent release. The reason is because I want to have XDP tools and libxdp. Those library I think does not exist in other distribution. So yeah, that's the main reason I wanted to use this Ubuntu 24.04 release. And so that's one change here. And so I also run the Suricata git clone the Suricata repo from my own GitHub repo, because that's where I added the eBPF XDP SymFlat protection patches. And yeah, so and then after we cloned the Suricata repo from my GitHub, we can then generate the makefile and compile the Suricata and configure the Suricata build script with enable eBPF and also enable building the eBPF program. So after that, we can install the Suricata configuration file and install the eBPF. And so after everything is built, and then we can actually build the container with those libraries required, including libxdp tools and libxdp library, right? So yeah, actually we can start the build. So here is I cloned my repo, Docker Suricata repo. We can go to 6.0 directory. That's where I made the changes, and then we can build the let's run this build program, deploy.sh dash build to start build the image, build the container. Okay, so it's pulling all the Ubuntu packages. So this will take a little bit of while, and in the meantime, let's let it run, and we can continue to explain this Docker file. Okay. So after you install those eBPF program and the Suricata to the fake root, then when we actually build the container, we can copy those copy everything from the fake root to the container /root directory. So we also copy some Suricata YAML files. Like this Suricata XDP YAML file is for Suricata to is the Suricata configuration file to run the XDP DDoS. And I also have a BPF tool installed in the container. And this is the user space XDP SIM proxy program to update the port map that is going to be protected by the SIM proxy. Yeah, so when the Docker container start, it will first run the Docker entry point .sh script file, and we can look at the Docker entry. So this is where I also made a lot of changes to the original repo. So here since we needed to attach XDP program to the network interface from libxdp, we needed to mount the BPF FS file inside the container. And this is the Suricata configuration file we're going to use. So this is in the entry Docker entry point script. And this is the interface. We can give at startup time, we can specify the Suricata option to specify the interface we want to attach the XDP program to. So this is some changes I made to handle the terminate signal, so we can do some cleanup after the container stops. So this is where see here we first prepare a terminal bash function, and then we start the Suricata in the background, and then we sleep 30 seconds, wait for the XDP program, wait for the Suricata and the XDP program to start up, and then we check if the program has been attached to the interface. If it is attached, we get the program ID, and then we set up the SIM proxy IP table rules, and also populate the port map. Okay, so and let's see our build. So it's still running the build, and by the way, since I already built the image, we can just go to deploy the container. So here is my server. I wanted to deploy the Suricata Docker container. So here we do not have a Docker image, or we do not have Docker container running. But I already put the Docker images. This is the Docker image I built previously, and yeah. So now let's run the Docker container. So here need a explanation. So here is Docker run. Since we needed to attach XDP to the network interface, we needed the Docker container to be privileged, and with the net host to access the host network interface. We can run. So here is the since you're okay. Let's make it bigger here. Okay. Docker run. Yeah. So here is we map the container directory to the host to a host directory. So in that way you can customize your Suricata configuration. So Suricata can start up successfully. The reason is that because here the option, see here that here is the interface we want to attach XDP program to. We run in the AF packed running mode, and the interface is Ethernet 0. So in your environment, this interface might be different. So you need to use the different interface. But even you have the correct interface specified here, it is still will not, the Suricata still will not start up properly, I mean, it will start up properly, but the XDP program will not be attached properly because your Suricata configuration file also needed to have the correct interface with with matched this interface. Okay, so anyway, let's start the Docker. So this is same proxy ports I specified here to protect with this environment variable. So this is a Docker image. Okay, so let's start the Docker container, and now it's started, and then we can see the Suricata container started, and now we can check if everything is attached properly. So let's go to the Suricata container. Since we packaged the XDP tools in the container, we can use XDP loader to check the XDP program. So XDP loader status, it shows the SyncCookie XDP program, XDP hash filter program is attached to the network interface, the host network interface. Okay, so and we can also check. I also packed the BPF tool program, so we can check the BPF tool map, and this is SymProxy allowed port BPF map that we updated the port to be protected by SymProxy. So we can actually dump the allowed port BPF map to see if the port we want to protect is updated. So here we can see we have port 80, port 443 updated in the BPF map, right? And it is because when we started the container, we have specified here 80443, right? And the interface is ETH 0. So right? Again, that's the ETH0 with XTP program attached. We can also check the Suricata log file in the container. Let's grab XTP rakata.log. So we can see here in the Suricata log, we attached XTP filter program with a priority 100. So here's the priority 100. And we also attached XTP SYN proxy program with a priority 50. Here is a priority 50. Right? Yeah. So now we can do a test. So here is the ETH0 and the IP address. So from the client, so let's first BPF map. Let's check the container XTP SYN proxy map. So this map, the name values is where we store the SYN cookie counter. So whenever there's a SYN request coming in, the XTP program will generate a SYN cookie and increase the counter in this eBPF map. Let's so dump ID 182. That's the map ID. So here we can see it has this is where the SYN cookie counter increase. So we can watch this counter when we send the request to the server. Okay. So now, maybe I already have something running here. Oh yeah, because I have a Nginx server running on this server. So there is a request, some outside request coming, so I can see the SYN cookie value increased. But let's run our test here from our side. So say let's run a HPin3 SYN flood. I don't want to flood my server, so let's just give a 10 SYN request. So actually from the HPin3, you can actually see the server send the SYN-ACK with the source port 80 to this HPin3, and 1, 2, 3. So our counter should increase. Here it's increased. Right? Let's run. Yeah, so it's increasing. Okay. So now let's do a normal request to see if send a curl request to my server, and then the Nginx server respond. Right? So it should also increase the counter with this, because increase the counter. Let's run a while, so it will also do SYN cookie proxying for the normal request, for legitimate request, and also do SYN flood protection. Okay, so it's working and it's increasing. So now let's also start the SimFlood, right? And we can also actually run the TCP down on the server. Down to ETH0 port 80. Let's stop the injects. Let's stop this curl request, and then let's start the HPin. Let's start this HPin flood. I mean, it's not a really flood. I don't really flood my server. So we send a 10 request, sleep 5 seconds, done, while true, do. Okay, so I started the same flood request, and now let's run a TCP down on the server. We will not see the SIM packet because the XDP program already processed the SIM packet, send the SIM cookie, and which is way earlier than the TCP down. So that's the reason which is way earlier in the stack. TCP down is later in the stack, so it will not see the SIM packet generated by the SimFlood. Okay. So now, if you decide that, oh, I don't want to run this container, I want to stop the container, and it should remove everything. Stop Suricata. So the Suricata container is stopped. There's no more XDP SIM cookie protection, and we can. So this is now run on the host. We can run BPF program. There is no more BPF program net. BPF program net. BPF tool net, which is to dump the XDP program attached to network interface. So here we do not see network interface attached to the network interface. IP link list. We can also use IP link list to see there is no XDP program. So we BPF tool map. There is no XDP SIM cookie allowed port map or venues map. It's gone. So, and there is no IP table rules for SIM cookie, right? So if we send our SIM SimFlood is still running. Now we can run TCP down. We should see the SIM request coming from the SimFlood test, right? Okay, but now let's start the Docker again. Docker run. Now we deployed the Suricata container, and we can see TCP down again. So you can see that maybe it's not a, let's see, maybe it's still loading the XDP program. PS Docker XEC IT Suricata XDP Node status. Yeah, so it's loaded. Let's see the IP table rules. IP tables T rule. Yeah, so the IP tables now it's deployed. I think because I waited 30 seconds to set up the IP table rules, that's why we see the SYMPACT coming from the TCP down. But now we should not see the TCP down. We should not see the SYMPACT from the TCP down because everything is set up properly now. And the SYNX is still sending back to the HPin3. Yeah, so it's easy, right? And you don't need a, it's easy to deploy the container. So you can see here the container build is finished. And this is a Docker image. And I actually like tagged with the XDP to push it to the Docker Hub. Yeah, so please try this out, and it's easy. And yeah, again, back to the I think one thing I did not mention, I didn't say clearly in the beginning is Docker run. So I said when you specify the interface, you needed to have specify the interface here, but also your configuration here, say Docker exec. Your configuration. Let's look at the browser. Is what so your configuration here. This is the configuration file, the Suricata configuration file for AF packet. For AF packet, the Suricata have configuration has configuration here. And see here the interface ETH0. You need to the interface should be matched when you start the Docker container and with the option. And in this configuration file, you also should have the same interface name. So if you are running the container image from my Docker Hub, you cannot change this interface. That is already in the container file. So one option is you can build your own container image, and before that you modify this interface to your interface name, and but another option, the second option is the second option is when you run this, you populate the Suricata configuration file to your host, and then in your host, your current directory, this /etc directory, you modify the file and it will be saved. So next time when you run it, I can show you the README. It explains better than me here. Docker, yes, Docker. So let's go to the repo here. What the heck? Okay, so here the repo. So the repo actually, the main page has a, I think the original author did a very good explanation here. Log rotation, volumes, configuration. So here in the configuration, the easiest way to provide a Suricata a custom configuration is to use the host band mount for the configuration directory. So for example, here first you start up the container and with a local host volume, right? So it will create a default Suricata configuration file. Then you can modify your, customize your Suricata configuration file with that matches this here AF packet. With this matches your interface, and also with the, so you just everything, the rest is the same XTP program, right? And then after you customize your Suricata configuration file, it will be saved in the host mount, and then you run it a second time. With the same volume mount, your Docker or Suricata container will use the right configuration file. So yeah, so that's the trick. You don't need to build your own Docker image, but if you want, you can build your own Docker image with the right interface specified. Yeah. Okay. So hope this works. Thank you.